Here we're going to look at some more conditional statements. So we're going to introduce three definitions. The first one, the control positive of a conditional statement. So if we have a conditional statement, we can first we define the what's a control positive of a conditional statement. So the control positive, so this is a definition. The control positive of if P then Q is if not P then not Q. It's still a conditional statement. And this is actually one of the fundamental equivalence, fundamental laws of logic, because these two statements, conditional statements, are actually logically equivalent. You actually can, again, create a truth table to prove these two statements are logically equivalent. So here we're going to be focusing on the definition and how, given a conditional statement, how to find the contrapositive. And so this is actually used in a lot of proof problems. Okay, so let's see this example. If Howard can swim across the lake, then he can swim to the island. So we will call this one P, condition will be our P, and then Q. Now, by the definition, if P then Q, so let's use symbols to describe them. The contrapositive of, what's the contrapositive? Contrapositive of if P and Q is not Q, so that we take the consequence and we negate it. This implies to negation of P, and we negate the hypothesis and we actually switch them. So following the definition, the contrapositive of this statement will be, first you're going to jump to the conclusion, and we still keep it as a conditional statement. So we'll say if Howard can swim, cannot, because we got to negate the consequence, cannot swim to the island, then he cannot swim across the lake. And these two conditional statements are logically equivalent, which means they're talking about the same thing. Okay, now next we're going to introduce another variant of a conditional statement. So it's called the converse. This is the first definition we talk about, and this is the next one is a converse of if P then Q statement. In converse you don't have to do the negation, so all you have to do is to switch the condition and the consequence. So you will get if Q then P. So if Q then P. Well, using symbols, that would be, so what's the converse? The converse, you would just switch P and Q. So the converse of P implying Q, converse is Q implying P. So now we go back to the example, we can try to find the converse of the statement. And as we can see by the definition, all we have to do is to switch P and Q. So put Q as our hypothesis if Howard can swim to the island, then he can swim across the lake. But we need to know, pay attention here. Previously, when we introduced the concept contrapositive, this is equivalent to the original conditional statement. But a converse statement, these two here, they are not necessarily logically equivalent. So let's see here, these two, original statement and converse, they may not be logically equivalent. So these two are not. Okay, but these two are logically equivalent. And so if Howard can swim across the lake, and then he can swim across the island. But it doesn't mean if he can swim across the swim to the island, it doesn't mean that he can swim across the lake. Okay, now the last concept we're going to introduce is called inverse. Okay, and the definition is if P then Q, this time we will only negate both the condition and the consequence. So that would be if not P, then not Q. Now again, if we use symbols, then we get the inverse of P implying Q is keeping the condition still as a condition, but negating the condition, implying the negation of the consequence. So let's write down the inverse of the example. So if Howard can swim across the lake, we gotta negate that. So we will get if Howard, let's put it down right here. So following the definition, negate the hypothesis. If Howard cannot swim across the lake, then he cannot swim to the island. I'll move this. Okay, so here are these three different variants of conditional statements. Notice that only the contrapositive is equivalent to the original conditional statement. Converse and inverse may not be logically equivalent, which means they may not mean the same thing. So if original statement, the conditional statement is true, it doesn't necessarily mean the converse is true. If the original is false, it doesn't mean the converse is false. Similarly for inverse. But for contrapositive, if the original statement is true, then the contrapositive is true. If the original statement P implying Q is false, then the contrapositive is also false.